Yes, now we are going to discuss about the performance of centrifugal pump. Now we are going to do the experiment on to study the performance of the centrifugal pump. First, we should know about the main parts of this experiment. Here we can see that this is the measuring tank and this one is the sum. Here is the scale is attached. So this is what measuring tank. Come to the experiment. Here you can see that how much energy consumed by the energy meter disc. This is the energy meter disc and this is the pressure gauge to measure the delivery pressure, and this is the suction pressure. And in energy meter disc, the energy meter constant is available here. So for the calculation we should use this energy meter constant. Here you can see that 1500 revolution per kilowatt hour is there. For the calculation, this constant should be taken. So from the front of this experiment, we can see these are the things. For the calculation part, we require the vacuum head or a suction pressure head and delivery pressure, as well as the how much of the water is collected in the collecting tank. Here we will take for a 10 centimeter height how much of the time is taken for a 10 centimeter height. That can be noted down from this here with the help of the stopwatch. So this is the centrifugal pump here. The pipe above the pump, this one is we going to call as the delivery pipe, and the pipe below the pump and also connected to the tank, that one is going to call as the suction pipe. This is the suction pipe and this is what delivery pipe. This is the centrifugal pump. Here it is, the shaft is there. The shaft is rotated with the help of the motor. The motor is means what is the power is generated from the motor, that is transmitted to the centrifugal pump shaft through this belt drives. Here using this one we can measure the RPM revolution per minute. Using this sensor we can measure the revolution per minute. Here we can see that this is the pipe that is connected to the delivery pressure measuring pressure gauge, and here you can see the pipe. This one is connected to the vacuum pressure gauge. So this one is what we are going to call as the priming action. Priming action means what? Removing the air that is present in the centrifugal pump and also in the suction pipe and up to a certain height of the delivery pipe. Removing the air and filling the water in the centrifugal pump, suction pipe as well as the delivery pipe we are going to call as the priming action. So I will fill the water there, means to remove the air. Okay, the pipe as well as the centrifugal pump is filled with the water. So now I am going to close this one and I will conduct the experiment. I will take the which are the readings is required for calculation purposes. Okay, now we are going to conduct the experiment. First, with this wall, means what? For different flow rate we are going to conduct the experiment. Using this wall we can take the different readings. For different flow rate we can take the different readings. Same thing that can be done for the suction pipe also, but here we are not going to change the suction pipe wall, but we only change the delivery head wall and we will conduct the experiment. First I will adjust to the one flow rate. Later I will going to on this pump. After onning the pump, I will note down the reading from the delivery head as well as the suction head. Here in the suction head, the reading is in what? In mm of mercury. Have to convert into what? Kg per centimeter square, because delivery head the scale is kg per centimeter square and the vacuum head the pressure is in the mm of mercury. So these things I will be explaining the calculation part, and the same time I should note down the speed of the pump speed. In energy meter disk, here disk is there for 3 revolution of the disk, how much of the time is taken, that should be note down. After that one, in a collecting tank or a measuring tank, how much of water collected for a 10 centimeter height, that is also should be noted down. So I will start the experiment. Same thing I am going to do the procedure. First on the pump. So here we can note down the vacuum pressure and note down the pressure from the delivery head, note down the speed of the pump, then using energy meter disk, note down how much time is taken for the 3 revolutions. One second revolution, third revolution, fourth rotation, fifth rotation. So 5 rotation, the time taken is 17 seconds. So this should be noted down for the calculation purpose. So here also what the water is rising here. For a 5 seconds, I started the reading at 6 to 16. How much of the time is taken, that should be noted down. Okay. For a 10 centimeter height, the time is taken as the 20 seconds. 19.97 is there, that is 20 seconds. Similarly, the experiment is conducted for the different flow rates. As usual, all the readings should be noted down. Energy meter disk rotation, for a 5 rotation, how much of the time is taken, delivery head pressure, suction head pressure, as well as the speed, and finally for a 10 centimeter height, how much of the time is taken to collect the 10 centimeter of water. So this process is repeated for the different flow rate. The calculation part will be explained later.
Okay, now we are going to start the calculation part of the centrifugal pump. Just now we learned how to conduct the experiment for the centrifugal pump to find out the performance of the centrifugal pump. This is the theory part. See, the main part of the centrifugal pump is what the impeller, suction pipe, as well as the delivery pipe. And from the suction pipe, you should note down from the pressure from this vacuum pressure gauge, from the delivery pipe, and this is the delivery in the delivery pipe, find out the pressure from the delivery pipe. That is very useful for the calculation purpose. For the observation, collect the area of the collecting tank, energy meter constant, and efficiency of the motor is noted down as the 75%. Next, come to the tableau column. Take 4 or 5 readings. First, you note down the speed of the pump. Next, take the reading of the suction head, delivery head. See, that is note down from the pressure gauge. I'm going to show that sketch. See, this is the suction head pressure gauge. From here, note down the suction pressure, and this is the delivery pressure. Note down the pressure from here. So for the energy meter constant, here it is mentioned here mentioned here. Note down this energy meter constant, that is 1500 kilowatt per hour. Note down revolution per kilowatt hour. Note down the readings from here. And this is the area of the collecting tank that is mentioned itself on the experiment. These are the two observations should be noted down. And during the experiment, after running the experiment, note down these values as well as what? The speed. Next, come to the tabular column. So suction head is over, delivery head is over. Next, this is the total head. This is the formula is there. Next, time taken for 10 centimeter of water rise in the collecting tank. That should be done. How much of the time is consumed for the rise of water in the collecting tank? I'm going to show that sketch here. For 10 centimeter height, how much time is taken to collect the water for this much of height? That should be noted down. And similarly, one more reading should be noted on. Number of revolutions in the energy meter reading, number of revolution of energy meter disk, and how much time is taken. For example, you consider there is a 5 revolution of energy meter disk, 5 revolution of energy meter disk. How much time is consumed? Once again, I will going to show that sketch here. See, this is what energy meter. Energy meter. Here is the disk is there. We have to calculate for a 5 revolution of the energy meter disk, how much of the time is consumed with the help of the stopwatch. This is the reading should be noted. So first is what? The observation. What is the energy meter constant? And what is the area of the collecting tank? This is the observation. Later, during running of the experiment, note down the value from pressure delivery head and suction head, that is vacuum pressure. Note down the speed for a 10 centimeter height, how much time is taken to collect the water. Later, 5 revolution or a 3 revolution of energy meter disk, how much of the time is consumed? That should be note down it. These are the calculation. These are the values should be noted down during the experiment for the calculation purpose. Once you note down the calculation, later, now we have to convert from in mm of mercury to the in kg per centimeter. Suction head is in mm. To convert into kg per centimeter square, this is the equation. This is the term. Just divided by 760, that will be converted into the kg per centimeter square. Now, the suction head pressure is also in kg per centimeter square. Delivery head is also in kg per centimeter square. Now, this should be converted into the meter by using multiply by 10. This is the HS plus HD whole multiplied by 10. Now, the total head is in terms of meter. And for a 10 centimeter height, how much of the time is taken? That is should be noted down. Then from the Q actual can be calculated by this equation. Area, this area means area of the collecting tank. H is the 10 centimeter. How much of the time taken? This is the Q actual. Calculation part here. Next, output power. To calculate output power, this is the equation rho into Q, rho into G into Q into H. Q is the actual discharge. Just now we calculated. This is the Q, and H is the total head. That is what finally we multiply, adding this to one, HS plus HD in kg per centimeter square multiply by 10. This is the capital letter H. That is what total head. Using this equation, you can using this equation you can calculate the output power. Next is input power. Input power. Input power is what here? This is the input power. K into 3600 divided by EMC into T. K is the number of rotation of the energy meter disk multiplied by 3600 divided by, this is the energy meter constant that is also available in the energy meter, into how much of the time is taken for 5 revolution of the energy meter disk. From this one, you can calculate the input power. After that one, the efficiency is calculated by output power by input power. So this is the calculation part. Very simple. First convert mm of mercury into kg per centimeter square. That is just divided by 760. Later converted into watt meter multiplied by 10. This is the remaining thing is as usual, the formulas are there. This is the part of the calculation part of the centrifugal pump.